Continue with half-life calculations using this formula, A equals A0 times 1/2 to the power of n. We're going to do example 2. We're going to find out the number of grams. Again, we're in notebook, page 64. This particular information is the same as example number 1. We still have carbon-14 emitting beta radiation and decaying with a half-life of 5,730 years. We're assuming that we start with a mass of 2.00 times 10 to the 12th grams of carbon-14. This time though, we're going to figure out this question using this information: how many grams of the isotope remain at the end of 3 half-lives? In the first video, we discussed that this formula is used only to calculate mass in grams. And we take a look here, it says how many grams. Therefore, we're going to use this particular formula. Now, because we have a formula and we have a word problem, if we list out the variables like we've been doing, it makes our work a lot easier. So A is the amount remaining, and the question says how many grams of the isotope remain. Therefore, that is the question. I'm going to put a question mark in. A0 is the initial amount. Back here in the information it says assume you start with a mass of, so start and initial are the same. So 2.00 times 10 to the negative 12 grams of carbon-14. This particular question tells us 3 half-lives, so n equals 3. I'm just going to do the math portion. I'm going to rewrite the formula. A equals A0 times 1/2 to the power of n. I'm going to then rewrite it with the numbers in it. A0 is 2.00 times 10 to the negative 12 grams times 1/2 to the power of 3. This is an area right here we need to get a number for. We have 2 options for finding that number. So we're going to do this first, and we have 2 options. So option A for figuring out what this number is when I take 1/2 and I raise it to the power of 3. You can take 1/2 and multiply it times itself as many times as the exponent and get a number. You're going to multiply the numerators. 1 times 1 times 1 is 1. 2 times 2 is 4. Times 2 is 8. Then I'm going to pick up my calculator and I'm going to do 1 divided by 8 so I get a number I can plug into my calculator, and I get 0.125. There are no units on that. Option B, you can do this in your calculator, which is good if you have an exponent here that's a really large number. You take 1/2, 0.5 represents 1/2, press the caret, and then the exponent 3. In this case, 0.125 is what you should get there also. Now that we have a number for this, I'm going to just rewrite this with the actual number, negative 12, and I'll be multiplying that times 0.125. This number is in scientific notation, so your exponent information is notebook, page 23. Keep in mind, you need to be able to enter in these numbers into your calculator to get the right answer. So I'm going to talk you through that. So you do 2 second function, the big E right above the 7 on your calculator that we use in class. It's x negative 1, negative 12, enter. And then I do times 0.125, enter. My calculator gives me 2.5 times 10 to the negative 13, and because there's no way to cancel that grams, I'm going to still carry the grams. This number right here is our significant figures. And if you need to review sig fig rules, notebook, page 25. This is a trailing zero situation. Therefore, everything counts here, and there's 3 significant digits. 2 and both zeros count. My calculator gives me 2.5. I have to know to add in this 0 so that I'm reporting 3 significant figures. So if we have carbon 14 and we start with 2 times 10 to the negative 12 grams, after 3 half-lives, which we found out earlier would be like 17,000 years, you would be left with 2.5 times 10 to the negative 13 grams.